So today we are going to talk about exact differential equation. If a differential equation is of the form like m dx plus n dy equals to 0, then it can be a exact differential equation if it obey some condition, and that condition is del m by del y must be equals to del n by del x. If this condition is satisfied, then the differential equation is said to be exact differential equation. What is the benefit of exact differential equation? The benefit of exact differential equation is that it can integrate directly. We can say that we can integrate like this: m dx plus n dy integration equals to some constant, and here remember that the integration of m dx, where m basically contains y or x term, and here in m dx integration the y becomes constant, and in n dy integration all the terms which contains x, the integration becomes 0. We can see it in an example. Let's take an example. Okay, so let's take an example that 2xy minus 9x square dx plus 2y plus x square plus 1 dy equals to 0. So first of all we have to check that if this is a exact differential equation or not. So this part is our m and this part is our n. So what we can do, we can differentiate like del m by del y, then del m by del y becomes 2x, and del n by del x becomes 2x. So we can see that here del m by del y equals to del m by del y equals to del n by del x. So this equation is a exact differential equation. If it is exact differential equation, then we can integrate both the side, and if we integrate both the side, then 2xy minus 9x square dx integration plus 2y plus x square plus 1 integration dy equals to constant. Then here integrating with respect to x, then it becomes x square y minus 9 x cube by 3, where y is taken as constant, and here integrating with y, then it becomes y square plus here x square integration of dy x square integration, it becomes 0, as we already talk about that all the x term in n part becomes 0 in integration. Then it becomes y equals to c, and if we write it as x square y minus 3 x cube plus y square plus y equals to c. Okay, and if there is some boundary condition or initial condition is given, then we can solve it. Like if there is a initial condition is a initial condition that y0 equals to minus 3. If it is given, then it shows that when x equals to 0, then y becomes minus 3. Putting this condition here, when x equals to 0, y becomes minus 3, then it becomes also 0, and minus 3 square it 9, and here minus 3 equals to c. So c equals to 6. Okay, if c equals to c, then putting the value of c in this equation, we get x square y minus 3x cube plus y square plus y equals to 6, and this is our solution for the exact differential equation. Let's talk about what happens if in a differential equation given, then del m by del y not equals to del n by del x. If del m by del y not equals to del n by del x, then the equation does not be a exact differential equation, it is a non-exact differential equation. Then we can solve this non-exact differential equation by converting it into an exact differential equation. To converting it into an exact differential equation, we have to do we have to multiply some integration factor, some integrating factor must be multiplied to make it exact differential equation. And there are different types of method. Basically there are 4 methods to convert a non exact differential equation into a exact differential equation. So first let us take the integrating factor. The integrating factor is equals to okay, let's take if del m by del y minus del n by del x by n equals to fx be a function of only x, then integrating factor becomes e to the power exponential of fx dx integration, and whatever be the integrating factor, that must be multiplied with the given differential equation, and then the equation becomes exact differential equation. Okay, there is also another formula to get integrating factor, that is del n by del x minus del m by del y divided by m equals to f of y, which is a function of y only. Then integrating factor equals to e to the power exponential of f of y dy integration. So these two formula are there to convert non-exact differential equation into a exact differential equation. Let's take an example to see which of the formula is applicable for which type of problem, and let's see. Okay, so our question is x sec square y minus x square cos y dy minus x minus 10y minus 3x fourth, 10y minus 3x fourth dx equals to 0. So first of all we have to check that is it a exact differential equation or not. Then here m dx and dy, here this term is m and this term is n. So del m by del y, and it becomes derivative of 10y is equals to minus sec square y, and del n by del x equals to sec square y minus 2x cos y. Okay, so now we have to subtract these two terms. As we can see that del m by del y not equals to del n by del x, so it is not a exact differential equation. We have to convert it into an exact differential equation in order to solve it. So we have to subtract del m by del y minus del n by del x, then it becomes minus sec square y minus sec square y plus 2x cos y. So we can see that it becomes minus 2 sec square y plus 2x cos y, and how can we divide it? Is it divisible by m or is it divisible by n? We can clearly see that if we divide it by m, then there will be a 10y term and 3x to the power 4 term is there, which is not in the upper part of this del m by del y minus del n by del x term. So we can't divide it by m, but if we divide by n, then it will easily comes to an simplified form. If we divide by n, then it becomes like this x. If we take out x, then it becomes x square y minus x cos y, and it turns out if we take minus 2, then it becomes x square y minus x cos y divided by x square y minus x cos y. So you can see that the whole the formula which we have to use is totally depend upon the situation. If the subtracting term is divisible by m or n, then only we use different type of formula. So it totally depend upon the difference value. So now integrating factor becomes e to the exponential of minus 2 by x dx integration. So it becomes exponential of minus 2 ln x equals to 1 by x square. Now multiply 1 by x square on this equation both side, then it becomes 1 by x square x sec square y minus x square cos y dy, then minus 1 by x square tan y minus 3x fourth dx, and integrate both side, and here is constant. Then it becomes if we integrate, then we can see that here all the x content term in n becomes 0, the integration becomes 0. So here if you take, there is 1 by x term is there, so this integration becomes 0, and only this term is which contains only y, so it becomes minus cos y integration of dy, and here is also 10 y becomes constant, and 1 by x square integration becomes minus 1 by x, and minus 3x square is here, so it becomes minus plus, and 3 here x square integration is equals to x cube by 3 equals to c. So it becomes cos y integration sin y minus sin y, and minus plus 10 y by x plus x cube equals to c, which is the solution of the differential equation, which is not in the exact form. So now let us take another example. Let take another example. X y cube plus y dx plus 2 x square y square plus x plus y fourth dy equals to 0. So here we can see that it is m and it is n, and if we differentiate both side del m by del y, then it becomes 3xy square plus 1, and del n by del x it becomes 4xy square plus 2, and as we can see that del m by del y not equals to del n by del x, so this is not in an exact differential equation form. So now we have to convert this. Now subtract del m by del y minus del n by del x, so that we can know which formula is applicable. Then if we subtract it, then if we take del n by del x minus del m by del y, then it becomes our del n by del x 4x y square plus 2 minus 3xy square minus 1, and what we have to divide, we have to check it. As you can see that here xy square, the after subtraction we get xy square plus 1, and it is divisible by m term, so we have to divide it by m, and m is nothing but that if we take out y, then it becomes xy square plus 1, then it becomes xy square plus 1 by y xy square plus 1. So now the integrating factor becomes e to the power exponential of 1 by y dy, so it becomes ln y, and exponential of ln y equals to y, and if we have now we have to multiply y on both sides. If we multiply y on both sides, then it becomes y into x y cube plus y dx plus 2y x square y square plus x plus y fourth dy equals to c. Here integration is taken place. So here all the x containing term have value equals to 0 in the integration, and only there is y fifth is here. So the integration is like y fifth integration is y sixth by 6, here 2 is there, and if we here integrate by x and y, all y term are constant, then it becomes y fourth, and it is x square by 2 plus y square x equals to c, then it becomes x square y fourth by 2 plus xy square plus y sixth by 3 equals to c. So this is the solution of the differential equation, and we see the to convert the non-exact differential equation into an exact differential equation, and we solve it, and there is other methods are there to convert it, and we should see it in next lecture series.